we're doing computing probability for compound events. That is when more than one thing happens at the same time. The first one to consider is the addition rule. Well, let's look at this first one. Consider the following table of 185 students to tell the probability of choosing a student in the agriculture or child care program. If they're joined by or, then you would add the two probabilities together. So let's get our calculator out. Agriculture or child care. So it's going to be a fraction of 21 plus 19, that's the agriculture, plus the child care, 27 plus 20, out of 185, because it says there's 185 children, and you get 0.47. Next one. Let's look at this one. Find the probability of, out of the 177 customers, of choosing an AT&T or a Vonage customer. So we would do AT&T. Let's get our fraction going. AT&T is 16 plus 15, and then Vonage is 22 and 20 out of 177 is 0.412. Next one. A bag contains 8 red marbles, 3 blue marbles, and 6 green marbles. Given the decimal probability for choosing a red or a blue. So red is 6, no, red is 8, and a blue is 3, and there's a total of 8 plus 3 plus 6 marbles, and so the probability is 0.647. Next one. 5, 5, and 5. Given the decimal probability of choosing a red or a green, so red is 5 plus green is 5 out of red plus blue plus green is 0.66666. Probability of rolling a 3 or a 5. Well, a 3 is 1 out of 6. Oops. Let's just delete that. 1 out of 6. A 5 is another 1 out of 6, which we could have said was 2/6, which is 0.333. Rolling an even number. Well, there's 2 is one even number, 4 is another even number, 6 is another even number, and there's a total of 6 numbers, so that'd be 0.5. Then you also have to do, okay, let's look at this one. Consider the table of the 156 students to tell the probability that if the student is a freshman, that they're in the ag program. Okay, so the numerator is the easy part. There's 12 freshman ag students, but the denominator is not the 156 students, but just those that are freshmen, the 12 and the 39 and the 23. And so we get 0.162. Child care, given the student is a freshman, that the student is in the child care program. So let's look at this one. Given that they're that should be, there we go. Okay, let's look at this one. To tell that if the student is a freshman, that the student is in the child care program. So the first thing we have to do is get the freshmen that are child care, 16, out of the total number of freshmen, 22 and 55 and 16. And we get 0.172. Okay, of the 163 students, phone customers, tell the probability that the person is a Vontage customer of choosing a smartphone. So the probability of a smartphone given that they're Vonage. Okay, so we've got a fraction of the smartphone Vonage people, 22, out of the total number of Vonage people, 22 plus 19, is 0.537. Next one. Probability that if the person is a voice phone, uses a voice phone, being an AT&T customer. So we have to get the probability of AT&T given that they're voice. So the numerator is going to be the AT&T voice out of the total number of voice, which is 18 plus 57 plus 17, and we get 0.185. Toss a dice. The probability that you roll is odd. If the roll is odd, that it is a 3. Okay, there's one way to get 3, and there are 3 ways to get an odd number, 1, 3, and 5, and that would be 0.333. Toss a dice. What is the probability, if it's even, that it's a 3 or a 5? So the denominator is even. So there's 3 different ways to be even, 2, 4, or 6, but none of those are 3 or 5, and so our probability would be 0. The last ones we have to do are using the multiplication rule. Let's look how that works. A classroom has 18 women and 17 men. What's the probability of selecting 2 women in a row from the room? Well, there's 18 women out of 18 plus 17. So that's the probability of selecting a woman first. This should be a multiply. So we're going to multiply those 2 probabilities together, and we get 0.257. Classroom has 16 women and 20 men. What's the probability of selecting a woman first, then a man? Okay, so we have 16 out of 16 plus 20. So that's the woman first. And then times probability of selecting a man. There's 20 men left, and there's only 15 women left, and 20 men left. And we get 0.254. A bag contains 4 red marbles, 1 blue marble, and 7 green marbles. What's the probability of choosing 2 blue marbles in a row? Should be 0, because there's only 1 blue marble to choose. Oh, it says with replacement. I missed that part. It says with replacement here. So, the probability of choosing a blue marble first, there's 1 out of 4 plus 1 plus, I forgot how many green marbles there were, 7. And then the second time, there's 1 blue marble because we put it back, and we have 4 plus 1 plus 7. I didn't see the with replacement. If it would have been without replacement, here's what we would have had. I can do that problem even though it's not the problem that is there. 1 out of 4 plus 1 plus 7 times, if we would have taken that 1 out, we would have had 0 as a numerator, 4 plus 0 plus 7. So we would have been multiplying by 0, and we would have gotten 0. Next one, a bag contains 6, 3, and 6. Choosing 2 red marbles in a row if the first is not replaced. Okay, so we have 6 out of 6 plus 3 plus 6. That's the first red marble, times, now we've only got 5 red marbles left out of 5 plus 3 plus 6, and we get 1/7, which is 0.143. Probability of rolling 2 3s in a row. Well, 1 3 would be 1 out of 6, times another 3, which would be 1 out of 6, is 1 out of 36, which is 0.0277 or 0.28. Rolling a 3 and then an even number, for that one, we would have 1 out of 6. Oops, what happened there? 1 out of 6 times even. Well, there's 3 ways to get an even number out of 6 ways. So 1 out of 6 times 3 out of 6 is 0.083. What's the probability of selecting 2 men from the room? Probability of a man and another man. So we have fraction 17 out of 18 plus 17 times another fraction, 16 men left out of 18 plus 16 is 8 out of 35, which is 0.229 when you get done. So this is lesson 5.8, computing probabilities.